So we learned, I'm not going to listen into the whistling, so stop it. So we learned SOHCAHTOA. What does SOHCAHTOA do for us? Helps us remember what? Yeah, it helps us remember sine, cosine, tangent. So I'm going to write that at the top. I think it's really important. So I'm going to write so. You have no space on the top at all? So then, okay. So then write it on the side. Write it off to the side. So, ka, toa. SOHCAHTOA. Sine equals, there's three types of sides of a triangle. There's the opposite, the adjacent, or the hypotenuse, right? So O stands for opposite. So if sine is OH, that's the opposite over the hypotenuse. The opposite over the hypotenuse, okay? So I think that the easiest way to do this is let's just label the sides of our triangle. How about if we call this side X, side Y, and side Z? Are you guys okay with that? So if I wanted to set up the ratio for the sine of A, so from angle A, the opposite side is Y over the hypotenuse is Z. Does everybody see that? If I wanted to set up for the sine of B, from angle B, the side opposite is X, and the hypotenuse is Z. Yeah, the hypotenuse never changes, right? The hypotenuse is always opposite the right angle, always. So you just have to figure out which side is opposite and which side is adjacent. Remember that the opposite side doesn't touch the angle, the adjacent side does, okay? So when we look at these triangles that actually have measures on it, I'm going to call this H for hypotenuse, and I'm going to label this side H for hypotenuse, because that does not change, right? The hypotenuse doesn't change. So when I need to find the sine of A, well, let's see. The opposite of A is 3, and the adjacent is 4, right? So sine, opposite over adjacent, or sorry, shiitakes, opposite over hypotenuse. That's 3 over 5. 3 over 5. Now let's label the sides again. Hypotenuse doesn't change. But in reference to angle B, the opposite side and the adjacent side. Notice that the adjacent side touches angle B, the opposite side does not. Do you guys see that? Colt, does that make sense? Okay, so sine, opposite. So sine of B, the opposite side, well, that's number 4 over the hypotenuse, 5. Okay, when you guys take your test on this, I think it's a good idea. Like, it's a good practice to use a colored pencil and use 2 different colors, right? Because you're going to have to look at it from 2 different angles. So again, going from A, we've already labeled the hypotenuse. So if angle A is our reference, and I'm going to call it like that little symbol theta, what's the opposite side going to be? 15. The adjacent is 8. So the sine of angle A is the opposite, which is 15, over the hypotenuse, which is 17. And let's do from angle B, and I'm going to call that alpha. Just looks like a little fish symbol. Okay. So what is the opposite of angle B? 8. And the adjacent is 15. The hypotenuse doesn't change. So if I want to find the sine of B, it's going to be 8 over 8 over 17. Carly, is that your phone? Okay. Are we good with that? Everyone has that filled out? Okay, I'm going to shrink it up and we're going to talk about cosine. So cosine, ka, A-H, let's see, that stands for the adjacent over the hypotenuse. Okay, so I'm going to call these sides J, K, and M. So from angle A, what side is adjacent? Meaning it's touching angle A, and then the hypotenuse. Adjacent side and hypotenuse. J and K. So it's J over K. Kane, we just started filling out that like neon yellowish colored thing from yesterday. From angle B, what is the adjacent side over the hypotenuse? Remember, the adjacent side touches the angle. M and K. All right. Let's label all of the sides in reference to angle A. So in reference to angle A, which one represents the hypotenuse? 34. Give it a capital H. Which one represents the opposite? 30. Give it a capital O. Which one represents the adjacent? Let's do the same thing for the next angle. Angle A, which one represents the hypotenuse? Which one represents the opposite? And which one represents the adjacent? Okay. So the cosine of angle A, first triangle, the cosine of angle A is the adjacent over the hypotenuse. What's that going to look like? Can you reduce that? You can. They're both even. We can divide it by 2. So that's actually going to equal 8 over 17. 8 over 17. Okay, I'm going to go right to the next triangle. We're going to just keep on angle A for a second. Cosine of angle A for the next triangle. Adjacent over hypotenuse. What's that going to be? Say again. Next triangle. Next triangle. Go to the next triangle. Cosine of angle A. Adjacent over hypotenuse. 7 over 25. Okay. Now we're going to go to angle B, Colt, because that's where you were. So I'm looking at angle B. Let's label our sides based off of angle B. So for the first triangle, what is the hypotenuse? 34, H. What is the opposite? And the adjacent? 30. Let's go to the next triangle. Hypotenuse. Opposite. Adjacent. So for the first triangle, the cosine of B, 30 over 34. Can I reduce that? Well, they're both even. They're both divisible by 2. 30 divided by 2 is? And 34 divided by 2 is? Perfect. 15 over 17. The second triangle, the cosine of B, adjacent over hypotenuse. What's that going to look like, Colt? Oh, thank you. 24 over 25. It's okay. It's all right. So the cosine and the sine both use the hypotenuse. One of them uses the opposite side, so the other one uses the adjacent side. The tangent is the only function that doesn't use the hypotenuse. Did you guys notice that? No hypotenuse. Will, I filled one of these out for you. Okay. No hypotenuse. So let's see. The tangent is the OA, TOA, right? SOHCAHTOA. TOA. So that's the OA. So that's the opposite over the adjacent. Opposite over the adjacent. So I'm going to label my sides again. Let's see. Let's do P, Q, and T. Is that okay? P, Q, and T. Okay. So in reference to angle A, the tangent of angle A, well, that's the opposite, which is side T, over the adjacent, which is P. In reference to angle B, the opposite is P over the adjacent, which is T. And I said yesterday, oh, wow, look, the tangents are reciprocals of each other. We said that yesterday, okay? So I'm going to go to this first triangle. In terms of angle A, I know that 25 is my hypotenuse. What side is my opposite and what side is my adjacent? Kane. Opposite, adjacent. Which sides? Give me the numbers.
20 is opposite, 15 is adjacent.
Awesome. So Kane, go ahead and set up the tangent of angle A.
20 over 15.
Can you reduce 20 over 15?
Yes.
So 4/3. Good job. Can I stay with angle A and go to the next triangle? Is that okay? Okay, Draco, I'm coming to you, and I know you weren't here yesterday. What are you going to call the hypotenuse? 29, 20, or 21? Perfect. Which side is the opposite side and which side is the adjacent side? Remember, the opposite doesn't touch the angle. Awesome. Perfect. So if I needed the tangent of angle A, what is the opposite over the adjacent? Perfect. Perfect. Parker, I'm coming to you. I'm going to go back to the first triangle. Now we're going to label the sides in terms of B. Okay. So going back to the first triangle, we know that the hypotenuse doesn't change. What side is going to be the opposite side, Parker, and what side is going to be the adjacent side from angle B? From angle B, what side is opposite? And what side is adjacent? 20. You see how I'm changing the colors up on you guys so you can see what's going on? Kind of keep track of it. So the tangent, Parker, of angle B, opposite over adjacent, is what? Can I reduce 15 over 20, Parker? What does that become? Remember, we said that the tangents are reciprocals of each other. So look at the one right above it. What's the reciprocal of that? So what's the reciprocal of it? 3/4. Both can be divisible by 5. So it equals 3 over 4. Okay. Good job. Yeah. Tangent of B. Tangent of B. All right, Luke. From angle B, name your sides. OHA. Okay. So what is the tangent of angle B? Perfect. 20 over 21. How do we feel about that? We good? See how they're reciprocals of each other? Okay, flip it over. So I want you guys to do this. We are only going to do the first two of each. So I want you to do this, kind of draw a little squiggly. You're going to divide your paper because the first two examples deal with missing sides. The last example of every function deals with a missing angle. And you're not going to learn that lesson until tomorrow. Okay. No, because we're going to do it tomorrow. We're going to finish our yellow thingy tomorrow. Okay. All right. So let's go up to the top. So I need to figure out the missing angle. Or not the missing angle. Sorry. I need to figure out the missing side. So it tells me that I'm using the sine function, which I know is opposite over hypotenuse. Opposite over hypotenuse. So the sine of 29 equals the opposite over the hypotenuse. How do I solve that? How do I go about getting x? Multiply both sides by 34. Multiply both sides by 34.
Wasn't this our homework last night?
It was. I just want to make sure you have a handout of it. Multiply. I'll take yours and fill out another one first. Multiply both sides by 34. So that's going to look like 34. Use your calculator. What do you have to make sure your calculator is set at? Degrees. Degrees. Go to the mode button. So 34 times the sine of 29 equals x. X equals 16.5. X equals 16.5. Is that what you got for that? Is that what I put on the answer key? You're kidding me.
There's the.
Thank you so much. Oh my goodness.
Yeah, man, I know you would give me this for free.
She did.
On three. 1, 2, 3.
What did she get it?
Okay. Okay, so next one. What are we going to do for the next one?
What is that?
It's a decoration from the OCS kids. Yeah. So what are we going to do for the next one? How are we going to set that up? Mode. So if you hit mode, you see you have radian and degree. You need to go down 1, 2, arrow over to degree. There you go. Enter. Okay, got it. So now, second click. Perfect. You're perfect. Okay.
Oh, it's not working. I think it doesn't work.
Yeah, it does work. You just hit second click and it's in the right mode. Okay, so we're going to set this up as the sine of 48. The sine of 48 equals the opposite, 24 over the hypotenuse, x. What did I say to do when you have x in the denominator? Switch places. X equals 24 divided by the sine of 48. And I'm going to draw a little arrow. We just switch places. Flop them, right? So let's see. 24 divided by the sine of 48 equals what? X equals 32.3. Is that right, Will? Perfect. Okay. That's using sine. Let's move on down to cosine. All right, cosine. That's the adjacent. Your adjacent over your hypotenuse. Adjacent over your hypotenuse. So the cosine of 32 equals the adjacent side over the hypotenuse. How do we get x all by itself, Carter? How do
we times by 28?
Multiply both sides by 28. Yep. So 28 times the cosine of 32 equals x. What do you guys get?
It's
23.7. 23.7 equals x. You guys want to practice this in your calculator to make sure you know how to do that, or all your answers are going to be wrong. Cosine 57 equals adjacent 42 over your hypotenuse. How do I get x out of the denominator? Trade spots. X equals 42 divided by the cosine of 57. What do you guys get? X equals what? Yeah, 77.1. Love it. Tangent. How do I set up tangent? What is that? Opposite over adjacent. Opposite over adjacent. So the tangent of 61 equals the opposite x over the adjacent 43. I have to multiply both sides by 43. So 43 times the tangent of 61 equals x equals 77.6. Whoops. That's going to look different than mine because we rounded up. Do you see that, Will? I left minus 5.7. Okay. What about the next one? Set it up for me, Tyler. That's right.
Tan 57 equals 48 over x.
Perfect. How do I get x out of the denominator? Trade spots. Trade spots. Okay. So x equals, well, x equals 48 divided by the tangent of 57.
0.842.
So x equals 48 divided by the tangent of 57, which is 31.2. So if you did not get that, you need to let me look at your calculator. Where were you yesterday when we did this in class? Okay, well, did you raise your hand ever? You really need to start. If you don't understand something, you got to ask questions, okay? Okay, so you're missing what I'm saying. If you don't understand, you got to ask. So let's do the first one. 43 times the tangent of 61 equals 77.57. We round it up to 6, okay? The second one, 48 divided by the tangent of 57. Okay, got it? Okay, all right. I'm going to go back to your module and show you guys